আছে এটা শেয়ার করুন। পেন একটা পেন রেডি করে ওইখানে রেখে দিন স্যানিটাইজারের পাশে। Okay, good afternoon all of you. In today's class, basically we'll be focusing, the main focus in today's class will be on the wavy curve method of solving inequalities. So that will be the primary focus of today's class. So inequalities by wavy curve method. Okay, so today actually we are going to have a class on inequalities, but in inequalities today essentially we will be focusing on the wavy curve method, because all the difficult sums of inequalities or the sums which are slightly unusual, they are all based on wavy curve method. So suppose there is this question, let's have a look, like solve all real x for which root over of x plus 1 into x minus 3 by x minus 2 takes real values. Okay, so you will have to find out all the real possible values of x for which this particular expression has real values. So we have to solve this question. Now to solve this question, we see that inside the square root you have x plus 1 into x minus 3 by x minus 2 inside the square root. So that means that if you want a real answer, then inside the square root whatever is there, it should be positive. So x plus 1 into x minus 3 by x minus 2, this number should be positive. So what you do is that you multiply above and below with x minus 2. So x plus 1 into x minus 3 into x minus 2 by x minus 2 whole square should be greater than or equal to 0, right? So x plus 1 into x minus 3 into x minus 2 by x minus 2 whole square should be greater than or equal to 0. So in order to solve this inequality, x plus 1 into x minus 3 into x minus 2 greater than or equal to 0, in order to solve this inequality, first you draw one horizontal line that is called number line. On the number line you plot the values of x for which this product is 0. So this product is 0 when x is minus 1 or x is 3 or x is 2. Okay, so these are the values of x for which this product is 0. So you draw one horizontal line like it's a graph without any y-axis. On this you plot the values of x for which this product is 0. So it is 0 at x is minus 1, x is 2 and x is 3. After that you draw a wave which should always start from the higher side of the first number. So the wave should start from above 3, cross at 3, cross at 2, go above, cross at minus 1, go below. So in this, whatever is above is positive and whatever is below is negative, right? That means that whatever is above the number line, for that this expression will be positive. Whatever is below the number line, for that this expression will be negative. So this is called the wavy curve method. So we want greater than or equal to 0, so that means we want positive or 0. So either x should be over here like more than 3 or it should be over here between minus 1 and 2. So the answer of this question will be that x will lie between minus 1 and 2, that is the one part, or x will be greater than or equal to 3, that is the second part. So the answer of this question, either x will be between minus 1 and 2, that is one answer, otherwise x will be greater than or equal to 3. So these are the two answers, x minus 1 to 2 or x greater than 3. So this is the way we can solve inequalities using wavy curve method. Okay. So suppose you have x plus 3 whole to the power 5 minus x minus 1 whole to the power 5 is greater than or equal to 244. So suppose you have an inequality like this, x plus 3 whole to the power 5 minus x minus 1 all to the power 5 is greater than or equal to 244. Suppose you have an inequality like this. Now in this inequality, so obviously you can see that it is power 5, so it's like a very big expression. You'll have to use binomial and all. So what we can do is that in order to make this sum a bit easier to solve, we can select a number which is average of x plus 3 and x minus 1. So we have to think of a number which is in between x plus 3 and x minus 1. So a number like which is the average of these two. So the average of x plus 3 and x minus 1, it will be x plus 3 plus x minus 1 by 2. So what will be the average of x plus 3 and x minus 1? It will be x plus 3 plus x minus 1 by 2. So that is coming to x plus 1. So let y equal to x plus 1. So let y equal to x plus 1. So x plus 3 to the power 5 it will be y plus 2 to the power 5. X minus 1 to the power 5 will be y minus 2 to the power 5. So y plus 2 to the power 5 minus y minus 2 to the power 5 will be greater than or equal to 244. Okay, so y plus 2 to the power 5 is y to the power 5 plus 5c1, y to the power 4 into 2 plus 5c2, y to the power 3 into 2 square, 5c3, y square into 2 cube, 5c4, y into 2 to the power 4 plus 2 to the power 5. And y minus 2 to the power 5 is y to the power 5 minus 5c1, y to the power 4 into 2 plus 5c2, y cube into 2 square minus 5c3, y square into 2 cube plus 5c4, y into 2 to the power 4 minus 2 to the power 5 is greater than or equal to 244 using binomial theorem. So what will happen is that as a result of this subtraction, these terms will cancel out. Okay, these terms will cancel out and whatever remains will be this. So 20 y to the power 4 plus 160 y square plus 64 is greater than or equal to 244. So 20 y to the power 4 plus 160 y square minus 180 is greater than or equal to 0. So y to the power 4 plus 8y square minus 9 is greater than equal to 0. So y square plus 9 into y square minus 1 is greater than equal to 0. So y to the power 4 plus 8y square minus 9 is greater than equal to 0. So y square plus 9 into y square minus 1 is greater than equal to 0. Now you draw so now y square plus 9 and y square minus 1 is y minus 1 into y plus 1 is greater than equal to 0. Now this is obviously a positive number like y square plus 9, so no need to consider that. So we have the wavy curve will look like this. So y will be greater than equal to 1 or less than equal to minus 1. So this product is greater than equal to 0, so y will be greater than equal to 1 or less than equal to minus 1. But y is x plus 1, so that means x plus 1 is greater than equal to 1 and x plus 1 is less than equal to minus 1. So x will be greater than equal to 0 and x will be less than equal to minus 2. So the answer of this question is x is greater than equal to 0 or less than equal to minus 2. So that is the answer of this particular question, which has to be done using binomial theorem. Actually, I was thinking of asking you to bring physics today, but I think I kind of didn't tell you to physics যদি আমরা করি মানে এরকম ভাবে তাহলে which topic is SSM or which Okay, next question is this the one? Yes. Okay. So next question is that solve 2x by 2x square plus 5x plus 2 greater than 1 by x plus 1. This is the next question. So all of you just try this question. I'll just come in a minute. By chance, যদি পরে যদি you want to do this, we can do it from YouTube after 5 o'clock. যদি করতে চাও, we can talk about it. Okay, so this is the question, all of you. Solve 2x by 2x square plus 5x plus 2 greater than 1 by x plus 1. So if you subtract this minus this, so 2x into x plus 1 minus 2x square minus 5x minus 2 divided by 2x square plus 5x plus 2 into x plus 1 is greater than 0. So ultimately minus 3x minus 2 divided by x into x plus 1 plus 2 into x plus 1 into x plus 1 is greater than 0. So 3x plus 2 by x plus 2 into x plus 1 into x plus 1 less than 0. So for this, x plus 2 into x plus 1 into 3x plus 2 into 2x plus 1 by x plus 2 whole square into x plus 1 whole square into x plus 1 whole square is less than 0. So if you draw the wavy curve, then using alternate plus minus x and otherwise x will be between minus 2 and minus 1. So there will be two possibilities for x. Either x will be between minus 2 by 3 and minus 1 or minus half, or x will be between minus 2 and minus 1. So these will be the two possible interval of answers for x using wavy curve. Okay. Next, have a look at this question. Solve 3x square minus 7x plus 8 by x square plus 1 lies between 1 and 2. This is the question. Okay, solve 3x square minus 7x plus 8 by x square plus 1 lies between 1 and 2. Now, for doing this sum, there are two inequalities. So, you'll have to solve each one with wavy curve and take the combined answer. So suppose 3x square minus 7x plus 8 by x square plus 1 is greater than or equal to 1. So 3x square minus 7x plus 8 is greater than equal to x square plus 1. So 2x square minus 7x plus 7 is greater than equal to 0. So x square minus 7x by 2 plus 7 by 2 is greater than 0. Now, how do we solve this inequality? 2x square minus 7x plus 7 greater than equal to 0. How do we solve this inequality? So if you divide by 2, then x square minus 7x by 2 plus 7 by 2 greater than equal to 0. So this you can write as x minus 7 by 4 whole square plus 7 by 2 minus the square of this number, minus 49 by 16 greater than equal to 0. So x minus 7 by 4 whole square plus 7 by 2 minus 49 by 16 is greater than equal to 0. So x minus 7 by 4 whole square plus 9 by 16 is greater than equal to 0. Right? So 2x square minus 7x plus 7 is greater than equal to 0. And by completing the square method, x minus 7 by 4 whole square plus 9 by 16 greater than equal to 0. But this is the perfect square. This is a positive number. So this and this together will already be greater than 0. So this inequality is always applicable. That means this inequality's answer will be all real numbers, right? So that means now we have to look at the other inequality. Like this one is less than equal to 2. So if you bring 2 to the left, then 3x square minus 7x plus 8 minus 2 into x square plus 1 by x square plus 1 is less than equal to 0. So it will come x square minus 7x plus 6 by x square plus 1 less than equal to 0. So x minus 1 into x minus 6 by x square plus 1 less than equal to 0. So less than equal to 0 means negative. So answer will be x between 1 and 6. So once again 3x square minus 7x plus 8 by x square plus 1 less than equal to 2. So if you bring 2 to the left and LCM everything, now the denominator is x square plus 1, which is already positive. There is no need to do anything about it. So we have numerator x minus 1 into x minus 6. So that has to be less than 0, less than equal to 0. So draw the wavy curve. So answer will be x lies between 1 and 6. So this is actually a very good sum where we are getting two places. Like one is the x square plus 1. It is confirmed positive. So whenever you get a confirmed positive number, then the inequality calculation becomes easier. For example, x square plus 1 is confirmed positive, so I am able to cross multiply it. Similarly, here also I am able to cross multiply because it is confirmed positive. The other is that in the first inequality, when I got 2x square minus 7x plus 7, I analyzed that this is a perfect square plus positive number, so obviously it is greater than 0. Okay, now modulus x minus 1 plus modulus x minus 2 plus modulus x minus 3 is greater than equal to 6. This is question number 5. Okay, so this time we have modulus inequality, right? Inequality containing modulus. How do we do this type of sum? See, in order to do this type of sum, you will have to use intervals. There is no other method. The reason is that a modulus either returns the same number or negative of the number, depending on whether that number is positive or negative. So there is no other way to do the sum except than taking intervals. So you can do like this. Suppose x is less than 1. Suppose x is less than 1. So 1 minus x plus 2 minus x plus 3 minus x is greater than equal to 6. Suppose x is between 1 and 2. So x minus 1 plus 2 minus x plus 3 minus x greater than equal to 6. Suppose x is between 2 and 3. That means x is greater than 2 but less than 3. So the first inequality, after solving, I am getting x less than equal to 0. The first inequality I am getting x less than equal to 0. The second one, I am getting x less than equal to minus 2 by 3, which is impossible because x has to be between 1 and 2. And the third one, okay, actually the second one is not this one. The second one is coming x less than equal to minus 2, which is not possible. Then the third one, I am getting x greater than equal to 6. That is not possible. Okay, because it has to be between 2 and 3. And then one more interval is there, x greater than equal to 3. So one more interval is there, x greater than equal to 3. So in that case it will become x minus 1 plus x minus 2 plus x minus 3 greater than equal to 6. So 3x will be greater than equal to 12. So x will be greater than equal to 4. So the final combined answer from all the intervals, either x greater than equal to 4 or x less than equal to 0. So this is the final answer after taking the combination of all the intervals, right? So remember, modulus inequality, there is no other way to do it. You have to take intervals, and because when you look at any modulus, then the answer of that will either be the number inside the modulus or negative of that number, so that will depend on the interval. So you have to take all possible intervals, and for every interval you will get an inequality answer. After you get the inequality answer, you have to check whether that interval which you have got lies in the original interval which has been assumed, like x less than 1 and x less than equal to 0. So this is acceptable because x less than equal to 0 will automatically be a part of x less than 1. So like that you tick whatever is there and cross whatever is not there, not applicable, and the answer is greater than equal to 4 and less than equal to 0. Okay, now suppose you have an inequality like this, modulus x minus 2 minus 1 greater than equal to 3. Suppose this is the inequality, you have to solve it. Okay, so suppose you have to solve this. Modulus of mod x minus 2 minus 1 is greater than equal to 3. So suppose you have to solve this. Okay. So to solve this, that number which is inside the mod, that is mod of x minus 2 minus 1, this whole number, like the one which is inside the mod, either it will be positive or negative. So suppose this number which is inside the mod is positive, that means mod x minus 2 minus 1 is positive. So mod x minus 2 is greater than equal to 1. So x minus 2 will be greater than 1 or x minus 2 will be less than minus 1. So x will be greater than equal to 3 or less than equal to 1. Meanwhile, if mod x minus 2 is greater than equal to 1, then this entire thing, it will break like this. So mod x minus 2 minus 1 will be greater than equal to 3. So mod x minus 2 will be greater than equal to 4. So x minus 2 will be greater than equal to 4 and x minus 2 will be less than equal to 4. So x will be greater than equal to 6 and x will be less than equal to minus 2, right? Okay, so x greater than equal to 6 is acceptable. This is acceptable because x has to be greater than equal to 3, and x less than minus 2 is applicable because x has to be less than equal to 1. So both these answers are acceptable, x greater than equal to 6 and x less than equal to minus 2. Both these answers are acceptable. Then we come to case 2. So case 1 is that modulus x minus 2 is greater than equal to 1. Now case 2 is modulus x minus 2 is less than equal to minus 1. Matlab, the opposite of this. Case 1 is modulus x minus 2 greater than equal to 1. Case 2 is modulus x minus 2 less than equal to minus 1. Less than equal to 1, excuse me. In fact, you can write less than 1 also. Okay, that is the opposite of this. So x minus 2 will lie between minus 1 and 1. So x will lie between 1 and 3. And if modulus x minus 2 is less than 1, then when you open this mod, so 1 minus mod x minus 2 is greater than equal to 3. So mod x minus 2 is less than equal to minus 2, which is completely impossible. The mod of any number cannot be less than equal to minus 2. So that means the final answer will be x greater than equal to 6 and x less than equal to minus 2. And as a result of case 2, we will not get any answer. So this is another example of modulus inequality. Now in this modulus inequality, it was a little more complicated than the previous one, because in this one we had to take two cases, and for each of the two cases, like the first of the two cases, there were two intervals and we solved it and got the answer. And in the second of the two cases, we took one interval, we solved it, but we didn't get any answer. So because there is a modulus within a modulus, so that's why you have to take two separate cases. I mean, like in the previous sum, what happened? We took separate intervals, right? And we got the answer. Here you have to take two separate cases because there is a modulus within a modulus. Okay, next question. Solve 9x square plus 8x plus 8 to the base 3x plus 5 is greater than 2. You have to solve this. Okay, you have to solve this inequality. Now, the thing is, any logarithm, there are three conditions. The number whose logarithm you are taking, that number has to be positive. The base has to be positive. The base cannot be 0. There are total three conditions. This number has to be positive, this base has to be positive, and the base cannot be 0. So first let us look at this number. So this number is positive. So 9x square plus 8x plus 8 is greater than 0. So 9x square plus 8x plus 8 is greater than 0. This number is positive. Okay, that is number 1. Now, this 9x square plus 8x plus 8 so you will get x square plus 8x by 9 plus 8 by 9 greater than or equal to 0. So x plus 4 by 9 whole square plus 8 by 9 minus 16 by 81 is greater than 0. Okay, now let's do the LCM of that part. So x plus 4 by 9 whole square plus 56 by 81 is greater than 0. So perfect square plus 56 by 81 greater than 0. So that means this is always true. So that means 9x square plus 8x plus 8 greater than 0 is always true. So that part is okay, taken care of. Secondly, the base has to be positive. And thirdly, the base cannot be equal to 1. So the base has to be positive. So 3x plus 5 greater than 0. So x greater than minus 5 by 3. And the base cannot be 1. So x cannot be minus 4 by 3. Right? So x has to be greater than minus 5 by 3, but x cannot be minus 4 by 3. Okay. So one by one, the number whose logarithm we are taking, it should be positive, that is confirmed. Number 2, the base has to be greater than 0, that we have found some answer for that. Number 3, the base cannot be minus 1, so we have found some answer for that, right? So what is left? The only thing left is the cross multiplication of 3x plus 5 to the right hand side. Okay, now this 3x plus 5 has to be either between 0 to 1 or it has to be greater than 1. Okay, there cannot be any other possibility because you know the base has to be positive. So either 3x plus 5 has to be between 0 and 1. Otherwise 3x plus 5 will be more than 1, but 3x plus 5 cannot be equal to 1. So if 3x plus 5 is 0 to 1, that means 3x plus 5 is a fraction. Now remember one thing, that if you take log of any number more than 1, the answer will be positive. If you take log of any number less than 1, the answer will be negative. Now if you say that 3x plus 5 between 0 to 1, that means 3x plus 5 is a fraction. In that case, the log of 3x plus 5 will be negative. So what you have to do is that for removing log, you have to transfer 3x plus 5 and change the inequality. So if I transfer 3x plus 5 to that side, so 9x square plus 8x plus 8 will be less than 3x plus 5 whole square. So 9x square plus 8x plus 8 less than 9x square plus 30x plus 25. So 9x square gets cut. So 22x greater than minus 23. So 22x is greater than minus 17. So x is greater than minus 17 by 22. And meanwhile, from this interval we got x lies between minus 5 by 3 and minus 4 by 3. So we are getting x lies between minus 5 by 3 and minus 4 by 3, and we are getting x less than minus 17 by 22. So okay. Now if you see carefully, then x greater than minus 17 by 22 and x between minus 5 by 3 and minus 4 by 3. So if you look at this answer and this answer, there is nothing common. So there is nothing common, like minus 5 by 3 to minus 4 by 3 and greater than minus 17 by 22. This answer and this answer, there is nothing common. So that means from 3x plus 5 lies between 0 to 1, there is no solution. Then we get another possibility, 3x plus 5 greater than 1. So if 3x plus 5 is greater than 1, then x is greater than minus 4 by 3. So 9x square plus 8x plus 8 will be greater than 3x plus 5 whole square. So 9x square plus 8x plus 8 will be greater than 9x square plus 30x plus 25. So x is greater than x is less than minus 17 by 22 and x is greater than minus 4 by 3. So if you take these two answers together, greater than minus 4 by 3 and less than minus 17 by 22, then the final answer will be this. So x will be between minus 4 by 3 and minus 17 by 22. So this will be the second answer. This will be the only answer possible for this sum, because for this interval we are getting a combination which is not giving anything in common. So for this interval 3x plus 5 0 to 1, it's ruled out. For the other interval we are getting greater than minus 4 by 3 but less than minus 17 by 22, and that is an acceptable answer. So this is our final answer for this particular question number 7. Solve question number 8. Solve log 6 to the base x plus 2 plus log 6 to the base x minus 2 is greater than log 6 to the base x plus 2 into log 6 to the base x minus 2, right? So in this question we are having logs to the base either x plus 2 or x minus 2, right? So how do we do this kind of a question? Now for solving this kind of a question, so I guess the wisest thing to do would be to split every log like this. So log 6 by log x plus 2 plus log 6 by log x minus 2 is greater than log 6 by log x plus 2 into log 6 by log x minus 2. So, like I said, the best suggestion would be to take an LCM. So, log 6 into log x square minus 4 by log x plus 2 into log x minus 2. So log 6 into log x square minus 4 by log x plus 2 into log x minus 2 is greater than log 6 whole square by log x plus 2 into log x minus 2. Okay, so now let's do one thing. Let us cancel one log 6 and bring this whole thing to the left. So like I said, let's cancel one log 6 here, one log 6 here, bring this whole fraction to the left. So log x square minus 4 by 6 divided by log x plus 2 into log x minus 2 is greater than 0. Okay, so this is our inequality right now. So log x square minus 4 by 6 into log x plus 2 into log x minus 2 divided by log x plus 2 into log x minus 2 whole square is greater than 0. So this is what we are getting. So we are getting product of 3 logs, this into this into this is greater than 0. Okay, now the issue is that these three numbers like log x square minus 4 by 6, log x plus 2 and log x minus 2, we can consider drawing a wavy curve. So for that we need to understand one simple thing, that these logarithms must be having some base. So the default base of any logarithm is 10. The default base is 10. So suppose log x minus 2 is positive, that means x minus 2 is greater than 10 to the power 0. So x is greater than 3. Okay, suppose log x plus 2 is positive, so x plus 2 is greater than 10 to the power 0, so x is greater than minus 1. And suppose log x squared minus 4 by 6 to the base 10 is positive, so x squared minus 4 by 6 is greater than 10 to the power 0. So x squared will be greater than 10. So x will be greater than root 10. X squared minus 4 by 6 greater than 6. X square minus 4 by 6 greater 1, so x square greater than 10, so x is greater than root 10 and less than minus root 10. Okay, right. So these are the intervals we have defined. So let's do one thing. Let's start from the rightmost interval. Suppose x is greater than root 10. Let's start from the rightmost interval. Suppose x is greater than root 10. If x is greater than root 10, then everybody is positive. This one, everybody is positive. So I'll do one thing. I will not draw a wavy curve. I'll just write positive. Okay. I won't draw the wavy curve. Let's see what happens. Okay. Now x is more than 3 but less than root 10. So if x is less than root 10, in that case this will be negative, this will be negative, right? But it is more than 3, so these two will be positive. So therefore the answer will be negative. Then let us consider x is between 3 and minus 1. So between 3 and minus 1, this thing is like negative, this one. Then this one is negative and this one is positive. So negative, negative, positive, so it's positive. So it's coming out like a wavy curve only. Okay, suppose x is between minus 1 and minus root 10, this is negative, this one is negative, then this one is negative, and in fact this one is also negative. So all are negative, so negative. Okay, so it is coming exactly like a wavy curve. And suppose x is less than minus root 10, then this is positive, but these two are both negative. So it's positive. So it's coming exactly like a wavy curve. So we could have drawn the wavy curve also. Anyway, so the answer is that your final answer must be greater than 0. So greater than 0 means that your interval should be greater than root 10 between minus 1 and 3 and less than minus root 10. So these have to be the answers. Okay, now there is one thing, 1 minute, I forgot one very, very important thing. While we are doing all this, one extremely important thing which we need to understand, we are doing log x plus 2 and log x minus 2. So x plus 2 and x minus 2 both has to be positive numbers. So x has to be greater than minus 2 and x has to be greater than 2, both. I mean, you cannot do log of a negative number. So x has to be greater than 2 and greater than minus 2. So if somebody is greater than 2, automatically that person is greater than minus 2. So x has to be greater than 2. So if x is greater than 2, that means we cannot have an answer below 2. So that means this portion we cannot have any answer. So our answer stands corrected. This positive part of wavy curve, forget it. 2 to 3 greater than root 10. So the final answer of this sum that x will be between 2 to 3. Okay, actually this is greater, not greater than equal to, so there won't be any equal to sign. So x will be greater than root 10 or 2 to 3, right? So the final answer of this sum, so this was an important thing, that after we finish the sum, we need to see that the number whose log you are doing has to be positive. So therefore x has to be greater than 2. So greater than 2 means 2 to 3, otherwise greater than root 10. So these two will give you the answer. That means the final answer will be the combination of this one and this one. So x square minus 3x minus 3 to the power x plus 1 is greater than 1. Okay, x square minus 3x minus 3 to the power x plus 1 greater than 1. Then you have to solve this, and the answer that you must get should be between minus 1 and infinity. So to solve this question, suppose if I take log on both sides, so log x square minus 3x minus 3 to the power x plus 1 is greater than log 1. So x plus 1 into log x square minus 3x minus 3 to the base 10 will be greater than 0. So x plus 1 into log x square minus 3x minus 3 to the base 10 will be greater than 0. So if log x square minus 3x minus 3 base 10, suppose this is a positive number, so suppose x plus 1 is positive and log x square minus 3x minus 3 base 10 is positive. So either x is more than minus 1 or x square minus 2x minus 4 is greater than 0. So x minus 4 into x plus 1 is greater than 0. So either x is more than 4 or less than minus 1 or between minus 1 to 4. Yeah, either x is more than 4 or less than minus 1, but we are getting greater than minus 1. So clearly x has to be greater than 4, right? So after taking log on both sides, this product is positive. So either x plus 1 is positive and this logarithm is also positive. And when both are positive, x is greater than 4. Otherwise, we can have another answer. X plus 1 is negative and log x square minus 3x minus 3 to the base 10 is negative. So x square minus 3x minus 3 less than 1. So x square minus 3x minus 4 less than 0. So this is the wavy curve. So x will be greater than minus 1 and less than 4. But the problem is that x has to be less than minus 1. That means this answer is not acceptable. Finally, for doing this sum, I took log, and you know that log of a number is only possible if the number is positive. So x square minus 3x plus 3 is positive. So x square minus 3x plus 3 positive. If you do factorization, then x minus 3 minus root 21 by 2 into x minus 3 plus root 21 by 2 is positive. So you know that this product positive will happen when x is less than 3 minus root 21 by 2 and x is greater than 3 plus root 21 by 2. So this product positive will happen either when x is this or x is that, and meanwhile x has to be greater than 4. So I think you will notice that if something is greater than 4, it is automatically greater than 3 plus root 21 by 2. So since x is greater than 4, it will automatically be greater than root 3 plus root 21 by 2. This answer, this part of the result is not coming into the picture. So the final answer of this sum is x greater than 4. So this is the way to do this type of a question. So in order to do this question, what we did was that we took logarithm on both sides. So you are taking logarithm on both sides. So you know that logarithm will only be successful if the number whose log you are taking is positive. So x square minus 3x minus 3 has to be positive, right? So that you did the calculation. And the product of two numbers is positive when each is individually positive or each is individually negative. So from there, each is individually negative, we didn't get anything, but each is individually positive, we got this, and therefore this is the final answer. Okay. Right. So we have completed all the different type of sums of we have completed all the different types of sums of wavy curve, right? So what are the different type of sums we saw today? So first we saw the very basic kind of sums where you just have to set up the expression greater than 0, less than 0, draw the wavy curve and do the answer. Then we saw the sum where a substitution was required, a very big binomial was coming, so a substitution was required to do the sum. Then we like after that we saw some where modulus was there. So for doing modulus inequality, we need to understand that the number whose modulus you are taking, if that number is positive, then the answer will be the number. If the number is negative, the answer will be minus of that number. And then we saw a few sums of logarithms. So in those sums of logarithms, we saw that basically you have to remember three things. The number whose logarithm you are doing, that number has to be positive. The base has to be positive, but the base cannot be equal to 1. So this summarizes the discussion. And now we are confirmed about the topic wavy curve, right? So on that basis, I'll conclude this session, and the next day we will be doing a different topic, right? So thanks a lot all of you, and I'll conclude this session now. Okay, bye all of you.